Hello and welcome. This is Cambridge O-Level Physics paper number 1, multiple choice. The subject code is 5054. This is May-June 2022 paper, and this is version 1 for this exam. Let's start. First question, it says a length of copper wire is labeled. Length is 0.5 meters and the diameter is 0.05 millimeter. Which instruments are most suitable to measure accurately the length and the diameter of the wire? So remember, the length of the wire, an ideal thing to measure the length of the wire is a meter rule. And similarly, a diameter of dimensions 0.5 millimeter, either vernier caliper or a micrometer is fine for measuring this. So let's see what options we have. So we have length meter rule, yes. Diameter, no. Then length meter rule, yes. Diameter micrometer, yes, you can measure. Then length using vernier calipers, no. Meter rule, diameter, no. Length using vernier calipers, no. And then to micrometer, yes. So the best options we have is B. Next question. It says a driver drives a car at uniform velocity along a road. The driver sees a hazard and applies brakes. What is the car's motion as it moves through the thinking distance and as it moves through the braking distance? So remember, the driver is moving with a uniform velocity, and as soon as he sees an hazard, he starts thinking of applying the brakes. So during that thinking distance, the car actually started to decelerate, because you can say that the driver has lifted his foot from the pedal and the car starts to decelerate, and then he presses the brake. So deceleration starts as during the thinking distance, and similarly when the brake is applied, the deceleration also takes place. So deceleration during thinking distance and deceleration using the braking distance is the right answer. So answer A will be our choice. Next question. It says the diagram represents moon in its orbit around the earth. Which arrow represents the direction of the resultant force acting on the moon at the instant shown? So remember, the object is moving in a circular path, and in a circular if an object is moving in a circular path, the force or the resultant force on this object is towards the center. So the right option is A, and that force is also called centripetal force. Next question. It says the mass of an object is related to the weight and the gravitational field strength. Which equation shows the relationship? So we remember that, weight is equal to mass times gravity. And here we can also write as mass equals to weight divided by gravity. So this no, this yes, this no, this no. So answer B is the right answer. Next question. Question 5, it says a plastic cube of density rho is compressed so that each of its sides becomes 1/2 of its original length. What is the new density of the material of the cube? So for example, we have a cube. So this is a cube. So remember, the volume of a cube is, so this is length, so length multiplied by length multiplied by length, so that will be length cube. And mass, you can say that mass is given as m. So density is mass per unit volume. So this is the density, and we can write it as rho. So now what happens if all these lengths are reduced to 1/2 of their original length? So reducing them to 1/2 of their original length. So we can say that volume so that each of its sides become 1/2 of its original length. So L by 2 multiply by L by 2 multiply by L by 2. So the volume becomes LQ by 8. And overall mass is a intrinsic property. It remains the same. So density, again, rho dash, it becomes mass per unit volume, and this comes here. So we can write this as new density is equal to 8 times the previous density. So the answer would be D. Next question. Question 6, it says 4 glass objects have square bases of area, equal area. So all these bases have equal area. Which object is least stable? So the least stable will have the center of gravity more towards the upper side. So for example, if we find out the center of gravity, symmetric center, this is somewhere here. Similarly, if we are going to find out the center of gravity or the center of mass, you can say, just make lines like this. It will lie somewhere here again if you do the crossing, and if you draw lines like this, so it will have something like this, and like this. So wait, this is wrong, so it will be let me. So we can see that almost all these 3 figures have the center of gravity somewhere here, whereas if we draw straight line here, and if we try to draw a straight line here, this will have center of gravity more towards this side. So eventually, or we can say that this shape number C will be least stable. So this is how you can, on an actual paper, you can use a ruler to draw the lines. So whichsoever shape will have center of gravity more towards the upper side compared to the base will be least stable. So moving ahead, next question, question number 7. It says that the initial pressure of a volume V1 of a fixed mass of gas is P1. The gas expands at constant temperature until the volume V2 and the pressure P2. So remember the case P1 V1 over T1 is equal to P2 V2 over T2. So we have to keep the temperature fixed. So T1 is equal to T2. So the relationship we have P1 V1 equals to P2 V2 is, and this is equal, and this is basically a constant at the moment. So which statement about pressure and volume of gas is not correct? So remember, pressure is measured in Newton per meter cube. So remember, pressure is force per unit area, kilogram per meter square. So no. So similarly, pressure is multiplied by volume. Pressure multiplied by volume is a constant. Yes. P1 V1 is a constant. Yes. And so this statement is not correct. Similarly, pressure is measured directly, is directly proportional to inverse of volume. So remember, PV is equal to constant. So pressure is directly proportional to 1 by V. Yes, so this is true. The ratio of V1 to V2 is equal to P2 by P1. So if we simplify this ratio, we get P1 V1 equals to P2 V2. Okay, so this is also correct. So let's see this statement. So remember, pressure is force per unit area. So unit of force is newtons divided by area is meter square. So it is Newton per meter square, not or kg per or yes. So Newton per meter square, not kg per meter square. So actually, these are the units for pressure. So yes, A is the not the right answer. So answer A is the our choice. Next question. It says a stone falls at terminal velocity in air. What is equal to the change in gravitational potential energy of the stone? So remember, say if this stone is at this location, and this is the ground we have, it is falling with a terminal velocity. So it means that it will have a kinetic energy and it will also have a potential energy because of this height. Okay, so this is up and this is your stone. So this is falling downwards, and if it's moving with terminal velocity, it means that the kinetic energy will be given as half mv terminal square. So, and terminal velocity is constant. So just simply we can say that the kinetic energy will not change till it hits the ground. And whereas the potential energy, this will keep on decreasing. So law of conservation of energy states that the total energy remains same. So this energy will be converted into some other form of energy. So let's see what happens here, or what are the options we are given. So change in kinetic energy, no, there is no change in kinetic energy. The kinetic energy will remain the same. Change in temperature of the stone, we can think of that because of friction and anything else, but doesn't look much convincing. The friction between stone and the air, energy will be going that way, yes, but it's not again a convincing statement. Then the thermal energy produced. So yes, so these 2 points are actually covered in this statement. So this as stone is falling, the potential energy is actually converted into the change in thermal energy that is produced across because of the change in because of friction, the temperature of the stone ranges, things like that. So answer D is the best rooted statement for this answer. Therefore, we'll go with this option. Next question. It says water in a river is used to turn a turbine as it flows downstream. This is type of how this type of power source described. So this is actually an example of a dam, and dam is a hydroelectric source of power. So answer A is the right answer. Remember, tidal is because of the sea and the ocean waves. Geothermal is the geothermal energy from the earth, and the nuclear power plants are again different form of energy. Next question, question number 10, it says that a load is pulled by a rope attached to a motor. The resultant force exerted by the rope on the load is shown in the diagrams. Each diagram, the load moves in the direction of the force and takes 10 seconds. So the time is 10 seconds and distance traveled is 1 meter. Which diagram does the motor works with the greatest power? So remember, we have to calculate power, and power is work done per unit time. So work done is equals to force multiplied by of F dot D, or so for first case 12 Newton multiplied by 1 meter. So this is 12 joules of work divided by time of 1 second, time of 10 seconds. It will be power will be 1.2 watts. Similarly, for this case, 8 multiplied by 1 divided by 10, this is 0.8 watts. Similarly, for this will be 1.0 watts. 10 multiplied by 1 divided by 10. This is 10 watts, and this is again 4 multiplied by 1 divided by 10.4 watts. So which diagram does the motor work with the greatest power? Answer is A. Power in A is the greatest. Next question. It says total energy. Really sorry. It says the total energy incident in 1 second on a group of solar panels is this much, 120 joules per meter square. A group of solar panels convert 720 joules of energy to 120 joules of useful electrical energy in 1 second. What is the total surface area of the panels? And what is the efficiency of the systems? Remember, the input energy is 720 joules, output energy is 120 joules. So the efficiency will be simply 120 divided by 720 multiplied by 100. So this comes out to be 1 by 6 multiplied by 100. So this is approximately 17%. Okay, so answer efficiency, these two will be the best. So then the area. So the total energy that is produced is 720 joules, and in 1 second, 120 joules per meter square. So from this energy going to this energy, it means that 120 joules per meter square multiplied by say x meter square will give us 720 joules. So meter square cancels with meter square. So the value of x is 720 divided by 120 is equal to 6 meters. So answer 6 meters will be this. So A is the best choice we have. Next question. It says a 1000 watt 240 volt electrical device is switched on. How much energy does it use in 5 minutes? So remember that the energy is given as power consumed per unit or in certain, or power consumed per unit time, or similarly or the units are watt into hours, or not watt hours, just simply joules, you can say. Energy is joules, and this is so power is 1000 watts, and time is 5 minutes, and so time should be in seconds, so multiplied by 60. So 1000 into 5, 300. So 300,000 joules, A, B, C, D. So answer D is the right choice we have. So next question. Question number 13. It says a building has walls made from wood and steel. What describes the way in which thermal energy is transferred through the walls? So number one is conduction through the wood by movement of molecules through the wood only. So remember, wood and steel are there, so the word only doesn't suit well, and then conduction through the wood. Wood is an insulator, so not much of a thing. Conduction through the metal by both vibration of particles and movement of electrons through the steel. Yes. So metals, again, vibration of particles and movement of electrons are cause of transfer of energy or thermal energy. So this statement looks good. Then it says conduction through wood. Again, wood is an insulator. I'm not sure it will conduct as good as a metal. So again, movement on vibration of molecules. Yes, it happens in the wood, but no, it's an insulator. Convection, no, convection doesn't take place in metals. So no. It's a process that takes place in gases and liquids. So the answer B is the best choice we have here. Next question, question number 14. It says a liquid column in a liquid in glass thermometer is 2 centimeter long at 0 degree centigrade. The column expands by 10 centimeter when heated to 100 degree centigrade. So measuring from P, so from this location, how long the column will be, how long the liquid column at 30 degree centigrade. So remember, 10 centimeters for 100 degree C. So it comes out to be 0.1 centimeter per degree centigrade. And we have to find out this length, and length is 0.1 centimeter divided by degree centigrade multiplied by 30 degrees centigrade. Centigrade cancels out, so this comes out to be 3 centimeter from this point. So 3 centimeters from here and from point P. So you just do not forget to add 3 plus 2. So it comes out to be 5 centimeters. So answer C is the right choice. Remember, some students will just simply write 3 and this will, it's a simple careless mistake. Please do not make such mistakes while solving this question. Next question. Question 15, it says that many applications, a thermocouple is used to measure temperature instead of a liquid in glass thermometer. Which property of thermocouple is a major advantage? So remember, liquid in glass, it takes some time. It's a slow, you can say not a very quick in response to change in temperature. So generally thermocouples are used where we need a very fast response. So it has a greater heat capacity. I mean, it depends upon the liquid or the material we are using. So it doesn't matter. The smaller temperature range, again, it doesn't, both of them doesn't give any applications in that. So it has a quicker response time. Yes, the thermocouple is much faster compared to a liquid in a glass thermometer. It has a non-linear output. I mean, everybody wants to use a linear device or a linear equipment. So answer C is the best case scenario we have at the moment. Then question number 16, it says liquid in glass thermometer consists of a bulb containing a liquid which expands into thin capillary tube. The liquid in thermometer is replaced by same volume. Remember, same volume of different liquid that expands more. Remember, expands more for the same rise in temperature. The length of the capillary tube, remember, they remain same. Okay. How does the new thermometer compare to the old thermometer? So remember what will happen. So this is, for example, this thermometer will allow us to measure, say, from 0 to 100 degrees centigrade, for example. Then if you're using the new liquid, what will happen? So the liquid will expand more for the same degree rise in temperature. So eventually for the new liquid, you may end up for a case, say 50 degrees centigrade, because the liquid expands more. You can't go above the 50 degrees centigrade because the length of the tube is no more available to us. But what will happen? So this sensitivity increases, and the range has decreased and it has become more sensitive. So you will be able to see more movement in the column, and you will be able to measure very minute amount of changes in temperature very clearly. So the sensitivity increases and the range decreases. So sensitivity increases and range decreases. So greater sensitivity, but a smaller range. So answer B is the right choice we have here. Next question, question number 17. It says that usual symbol, what is the usual symbol and the unit used for heat capacity of an object? So heat capacity generally by C, and the heat capacity is given as joules per degree centigrade. So this, remember, this is specific heat capacity. Specific heat capacity. And the symbol for specific heat capacity is small c, not capital C. So answer A is the right choice we have. Then it says, which question number 18, it says, which row describes the arrangement of particles and forces between particles in a solid? So solid has a regular arrangement of particles and strong forces between the particles. So regular and strong. 18, answer A is the best choice we have. Next question, it says a wave in the sea collides with a cliff. The crest of the wave hits the cliff once every 6 seconds. So for example, this is the cliff we have. So, and this is the wave that is coming. So this crest, this is the crest, this is another crest, this is a crest. So time difference between these two crests is 6 seconds. and the horizontal distance between the crest and the adjacent trough. So this crest and this trough is 4.5 meters. So actually a complete time period is 4.5 multiplied by 2, 9 meters. So now, so the total distance this requires to take is 9 meter, or it takes 6 seconds to cover this distance. So velocity is equal to distance by time. Distance is 9 meters, time is 6 seconds. So the answer is 3 by 2 meters per second, or 1.5 meters per second. And this is the velocity of the wave. Answer B is the right choice we have. Then question number 20, it says that sound wave refracts as it passes from air to water. So it passes from air to water, which quantity changes? So remember, V is equal to F lambda. So this is a sound wave. So remember, for a sound wave, if it's passing from any medium, so the frequency remains constant or same. So frequency remains same, the velocity changes, and the wavelength changes. So velocity or you can say speed and wavelength changes only. So during refraction, speed and wavelength, speed and frequency, no, speed and wavelength, yes, wavelength and frequency, no, all of three, no. So answer B is the right choice we have. Then question number 21, it says an object is viewed through a thin converging lens. The diagram shows the paths of two rays from the top of an object to an eye. How the image compared to an object? So image will be somewhere here. This is an upright image. This is a virtual image on the same side of the object, larger in size. So larger in size, inverted, no, upright, yes, smaller, no, inverted, no, smaller, no, upright, yes. So answer B is the best choice we have here. Then question number 22, it says a ray of white light enters the prism as shown. Which row is correct? So the wave observed here, what we are observing. So we are observing dispersion of light and refraction of light. So we are observing both dispersion and refraction phenomena. So answer, it would be either C or D. Okay. Then remember these light. So if we say VIB, GYOR, Vibgyor spectrum. So this spectrum lies in the visible light. And this visible light is somewhere between 400 nanometers to 700 nanometers. This is something that is with us. So this is infrared and this is ultraviolet. So ultraviolet is generally lower frequencies. So if this is low frequency, oh sorry, this is lambda. This is lambda, and we know that C equals to F lambda, and F is equal to C by lambda. So if lambda decreases, frequency increases. So it is F is here, so F is more over here, and frequency is less over here compared to this. So what we can say that the red light will have less frequency compared to the blue light. The frequency of red light compared to the frequency of blue light is smaller, so smaller. So answer C will be our best choice. Next question, question number 23, it says which waves are not part of electromagnetic spectrum? Radio waves, yes. Television signal, UHF signals, yes, they are electromagnetic waves. Ultrasound, so ultrasound are longitudinal waves, so they are not the part of electromagnetic spectrum. Ultraviolet, UV rays are again a part of electromagnetic spectrum. So answer C is the right choice we have. Then question number 24, it says a man stands between two tall buildings, P and Q. He is 50 meters from P and 200 meters from Q. He sounds a horn, hears the first echo from building P, and 1 second later he hears the echo from building 2. What is the speed of the sound calculated using this information? So remember, speed of sound will be same for our case. So let's call it V. So speed of sound is V. So time taken by first, and calculate the time taken by this. So T1, to calculate T1 is equal to distance divided by speed of sound. The distance is 50 meter divided by speed of sound is V. This is this seconds. Then calculate T2. T2 is distance divided by V. Distance is 200 meters. We divide by V. This is seconds. So difference in time is the duration or is equal to 1 second. The later it here. So 1 seconds. So if we say 200 by V minus 500 by V is equal to 1. So we can just simply say that this is, sorry, not 200. So distance travel will be this and then back. So it will be multiplied by 2. And then this is again, distance travel is this plus distance travel back. So twice. So 2. So 200 multiplied by 2. This multiplied by 2. So this is 400 minus 100 divided by V equals to 1. So this is 300 meters per second is equal to V. So answer B is the right choice. So always remember, in such questions, we generally see in textbooks that 330 meters per second is the speed of sound. So it's in such cases, always calculate the speed of sound. Do not go with the normal answer. And this is a mistake some students make while solving this question, because they do not do the maths. They just simply write down the answer and eventually it gets wrong. So moving ahead, next question, it says sound travels at different speed in each of the 3 states of matter, solid, liquid, and gases. Shows where sound travels fastest and where sound travels slowest. So the fastest is in solid, slowest in gas. So sound fastest in solid, slowest in gas. Answer D is the right answer we have. Next question, it says, which of the following, what is one of the uses of ultrasound? Cleaning jewelry? Yes. Ultrasonic baths are used to clean the jewelry. Fluorescence tube? No. They are not, I mean, it emits electromagnetic spectrum. Optical fibers? No. I mean, generally in optical fibers, IR at lambda equals to 1.3 micrometers or 1.55 micrometers wavelengths of infrared or near infrared wavelengths are used. Sunbeds? No. I mean, these are not. So answer A is the right choice for ultrasound, uses of ultrasound. Question number 27, it says, which material is used for a core of an electromagnet? So electromagnet, the material which use or which can be easily magnetized and demagnetized, and the only material here is C, iron. So aluminum, copper, and steel cannot be easily magnetized and demagnetized. Even for example, copper wires are used for conduction of electricity, and they have a very almost no magnetic properties. So answer C is the right choice we have. So answer C is the right choice we have. Next question, it says 2 metal spheres are mounted on insulating stand. Sphere X is initially uncharged and sphere Y is positively charged. So this is positively charged sphere. We call it positively charged. The metal rod held by the insulating handle and is placed in contact with X and Y. So these positive charge transfers on X as well. So this is an insulated, so easily. So what are the charges on X and Y after the rod is placed in contact with it? So as soon as you place the rod, so the static charges are transferred to sphere X. Both of these spheres will have positive charges. So if this, for example, this sphere will have, say, 4 charges initially, 2, 3, 4. After the rod is placed, this sphere will have 2 each. So the charges will be equally distributed. So and both of the charges will be positively charged. So answer A will be the best choice we have. Next question. It says, which device involves the use of static electrical charges? Computer hard drive disk? No. A motor? No. Photocopier? Yes. So remember, the drum of the photocopier machine is statically charged, while while performing the operation or while performing the photocopy of the material. And then again, transformer, there is no static electricity involved here in the transformer. So the answer C is the best choice we have. Then question number 30, it says an initially uncharged copper wire, copper rod is placed in a uniform electric field. Remember electric field. The rod is parallel to the field. So remember electric field flows from positive to negative. So this is positive side, this is negative side. That's how electric field goes. Which diagram shows the charges induced on the rods? Remember induced on the rods. If positive is here, negative is induced here, negative isn't induced here, positive will be here, something like this. So the charge will, the rod will have, let me draw it again. So the rod will have negative here, positive here. So the electric field is going something like this. This is electric field is going from positive to negative. This is E field. This is E field. So anything that relates to this negative here, positive here. So answer D suits the best in this case. So answer D will be our choice. Next question. It says the diagram shows a simple circuit. Which row describes the charge on an electron? So electron is negatively charged particle. And the direction of electronic flow from the resistor. So electronic flow is from the negative to the positive terminal. So remember electron flow from negative to positive, and whereas the conventional flow is from positive to negative. So negatively charged with negative to positive, so it means that from Y to X. So negative charge, yes. X to Y, no. Negative charge, yes. Y to X, yes. So answer B is the right answer, so no positive charges. So this is how this question can be done. Then next question, it says, when a flash on a camera is used, a charge, so remember charge Q is equal to 1.5 coulombs, flows for time is equal to 0.003 seconds through a flash lamp. The average voltage across the flash lamp, so voltage is also given 3600 volts. What is the electrical energy supplied by the flash lamp and the average power supplied? Okay, so now this is interesting. So remember, first of all, we know that Q equals to IT. If we calculate I equals to Q divided by T. So charge is 1.5 coulombs divided by 0.003. So this is the current, and power is equal to VI. Voltage is 3600 multiplied by current is 1.5 divided by 0.003. And if we multiply it, 3600 multiplied by 1.5 multiplied by 1000 and divided it by 3. So this comes out to be 1.8 into 10 to power 6 watts. Okay. So the only one term is here. So we can easily say that these three are not. So even if we, in such a question, even if you have calculated one of the values properly, you don't have to calculate. But anyways, let's try it. So the energy is, remember we have solved such a question earlier as well. Power per unit time. So just multiply 1.8 into 10 to power 6 multiply by 3 divided by 1000. So it comes out to be 5400 joules. So answer D is the right choice we have. Next question, it says, question number 33, it says, what is the unit of potential difference? Potential differences units are volts. And what is the measuring instruments used to measure potential difference? Potential difference is measured by a voltmeter. So let's see. Ampere, no. Ammeter, no. Ampere, no. Voltmeter, yes. Volt, yes. Ampere meter, no. Volt, yes. Voltmeter. Answer D is the right choice. So remember, current is measured in current's unit is ampere and is measured using an ammeter. Okay. Then question number 34. It says the diagram shows 4 circuits. Each of the circuit contains 300 ohm resistors. Which circuit has the smallest total resistance? So okay, now let's calculate the total resistance in each circuit. So this total resistance is 100 ohms plus 100 in parallel with 100 ohms in parallel with 100 ohms. So remember, parallel combination of two resistors are 1 in multiplied by R2 over R1 plus R2. So the parallel becomes in something like this. So this is 100 square divided by 200. So the answer will become 100 divided by 200. This is 50 ohms. So this becomes 100 plus 50, 150 ohms for this case. This three resistances are in parallel, 100 plus 100 plus 100. This is equal to 300 ohms. Similarly, this part B, three resistances are in series. So just add them. In part C, three resistances are in parallel. So 1 by RT, 1 by R1 plus 1 by R2 plus 1 by R3. So if we call it 1 by 100 plus 1 by 100 plus 1 by 100, this comes out to be 3 by 100, 1 by RT. So effective resistance becomes 100 divided by 3 ohms. So this is approximately 33.33 ohms. Okay. So now in this part D, what happens? So we have these two in series, so 200 ohms. And in this 200 ohms becomes in parallel with 100 ohms resistance. So the value of R total becomes 200 multiplied by 100 divided by 200 plus 100. So this is 200 multiplied by 100 divided by 300. These two, so 200 divided by 3. So this is approximately 60.60 6 point something 333 something ohms. So which is the smallest total? Answer is C. This value is the smallest value of resistance which we have calculated. So next question, it says a metal kettle is plugged into main socket. The plug contains a suitable fuse. The kettle cable is damaged and the fuse blows. Why does the fuse blow? So remember, whenever we add a fuse, say for example, this is fuse. So fuse is always added into a live wire. And this is, for example, our kettle, and it goes back via the earth wire. So if this wire is damaged, so what will happen? So in a low resistance path is developed, and in that low resistance path is developed somehow because of breakage of wire, and the wire comes, this is your live wire, and live wire comes in contact with the earth wire. That results in a low resistance path and a very heavy current flows. And when a very heavy current flows, this fuse blows off or melts. So this is a case generally what happens. So let's see. So the bare earth wire in the cable touches the bare live wire. Yes, it can be, looks good option to us. Yes. It says metal casing of kettle touches the bare earth wire. So we do not, the metal case is actually isolated. Else in worst case, if a person touches it, it becomes dangerous. So no. The bare neutral wire in the cable touches the bare earth wire. So neutral and earth, I mean, they do not have any relevance in this case. So no. Live wire breaks without touching any wire. So if live wire breaks and doesn't touch any wire, I mean, the fuse will stay, the circuit will be an open circuit, no current flows. So this is again not a case. So answer A will be the best option we have. Then question number 36, it says as a magnet is moved into the coil of a wire as shown, there is a small positive reading on the sensitive ammeter. Which change must increase the size of the reading? So This is again a case of electromagnetism. So if this magnet is moved forward, moved towards this coil, so in case to the reading to increase, either the magnet should move faster, or the number of turns on the coil should increase, or the coil should move faster. So if this coil is fixed, so the magnet should be moving faster, or we can use a bigger magnet or a stronger magnet. So let's see what are the options available. So moving the opposite pole to the coil, no, it doesn't affect the reading. So the pulling the magnet out of the coil, again, it will change the direction of the reading, but not the size of the reading. Pushing the magnet in faster, yes, it will change the magnitude of the reading. Unwinding some of the turns, so if we unwind some of the turns, it will decrease the magnitude of the reading. So eventually the best answer is C. Next question, question number 37. It says the diagram shows the output, shows the circuit for a model power line with two transformers and a lamp at the output. What is the input voltage? So let's see what we have here. So we have a transformer. So for transformer, say this is the secondary side, this is the primary side for this set. Similarly, for this set, we have this is as secondary of first case, and this is primary of first. So this is primary of second. This is secondary of second. So let's and we know that the turn ratio, number of turns on primary divided by number of turns on secondary, is equal to number of, or the voltage at primary over voltage at secondary, and it is equal to current at secondary over current at primary. So this is the transformer equation we have for an ideal transformer. So we are not concerned with current at the moment, so we can ignore this. So this is what we are left. So we have secondary, so number of turns available and the voltage at secondary. So let's find VP, VP2. VP2 is number of turns at primary 200 divided by secondary 400 multiplied by VS. VS goes here, it's 24. So VP2 is this 4, 6. So it is 12. So 200 divided by 40. So about this is 40. This so 20 into 6, 120 volts. So VP2 is 120. So we are now having 120 volts here. So 120 is here. So 120 volts will be appearing here. So there is no loss. So again, VP1. So VP1 over VP2 is VS1, sorry, is equal to NP1 over NS1. So NP1 is 10, NS1 is 100 multiplied by 120. VP1, this is this is 12 volts. VP1. Let's see if we have an answer here. So option A, B, C is the right option we have. So this is how we calculate it. So answer C is the correct answer. Then next question, question number 38. It says electrical power is transmitted by cables over long distances at very high voltages. What are the effects of using high voltages or a high voltage power transmission system? So if remember, so we are transmitting power from one point to another. Say this is 0.1, so this is 0.2. So this is 0.1, this is 0.2. So power, remember, power P is equal to VI, and the losses in generally in conductors can be given as I square R, or that or power loss you can say, or losses because of transmission of power. So what if we can somehow reduce this value of current, because the resistance is an intrinsic property of the wires, we cannot change, although we can develop interesting conductors as well. But assume, let's say we have a constant value of resistance, or how we can reduce the losses by reducing the value of current. So if we reduce the value of current for same power, we have to increase the voltage so that the product of VI remains constant. So in such a case, if we transmit at high voltage, the current is reduced, overall power remains the same, and it effectively reduces the I square R losses in the cable. So what is happening? So reduced losses and reduced current. This is actually what is happening in the cables at high voltages. So power loss in cables, low. Current in the cables, again low. So low and low. Answer D is the right choice we have. So answer 38, part D is the correct answer. Next question, question number 39. It says the diagram shows a beam of electrons about to enter a magnetic field. The magnetic field is directed into the page. What is the direction of deflection of electrons as they enter the magnetic field? So remember, the best way is to do, you use your left hand rule. So left hand, index finger points to direction of electrons. Middle finger is direction of magnetic field. And thumb force acting on the charges, whether it's positive charge or negative charge. So if the index finger is pointed towards the direction of electron beams, the thumb is going into the page. So that, the middle finger is going into the page, and then your thumb will be pointing towards downward. So in this case, into the deflection of electrons into the page, no, because magnetic field is into the page. Out of the page, no. Up the page, no. Down the page, yes. So answer D is the right choice we have. So next question, and the last question for this exam. So in this question, it says, in a Geiger-Marsden experiment, alpha particles are fired at a thin gold sheet. Most alpha particles pass through the thin gold sheet. A few are deflected. What can be deduced from this experiment? So most of them passes through the thin sheet. It means that nucleus is a very, very small entity. Wait. So it says that most of the alpha particles pass through the thin gold sheet. It means that the nucleus is a very small entity. Very few deflections. It means that there is some mass or charge associated with the nucleus. So eventually, charge and no charge. No, this is not the output or deduction from this. Electrons around the nucleus. No, this is not the experiment for that. Electron has a negative charge. Again, this is not the experiment at that. So again, answer A is the right choice for the Geiger-Marsden experiment, and one of the things that was deduced from this experiment. So this is how, or this is the last question for this exam, and I hope you have learned and enjoyed this video. And if you are going to give your exams, I wish you all the best, and stay tuned for more videos. And if you have any questions, please feel free to ask in the chat window. Thank you very much for listening. Take care.